I will lock the meeting after 5 minutes. Okay. We are in quantum numbers, and that too, I think we are in azimuthal quantum number, right? The second one is azimuthal quantum number or angular momentum quantum number. Azimuthal or angular momentum. Azimuthal or angular momentum quantum number. Okay, these important points we wrote, I think we are in examples. I am explaining again one more time with examples. For example, if n is equal to 1, if n is equal to 1, principal quantum number equal to 1, the possible L values are 1 only, that is L is equal to 0, and that is nothing but S subshell, and that too it belongs to 1s only. Why? Because this is first shell number. If n is equal to 2, the possible L values are L is equal to 0 and L is equal to 1. If L is equal to 1, that is S subshell. And if it is L is equal to 0, S subshell, and L is equal to 1, P subshell. Okay. And it belongs to second shell, that's why this is 2s, and it belongs to third shell, that's why this is 3s. Same like that. If n is equal to 3, Nana, if n is equal to 3, the L is equal to 0, that is S subshell, and L is equal to 1, P subshell, and if it is L is equal to 2, D subshell. Its value is 1s, 3s. Why? Because it belongs to third shell, and this is 3p, and this is 3d. Okay. Now your homework is, if it n is equal to 4, what is its value? Wait, Arshita, you can unmute. Can you hear me? Tell me the possible L values, Tali.
Sir, 3.
No. From starting onwards, if it is L is equal to 4.
From starting on L is equals to 0, S subshell 4s.
Okay.
L is equals to 1, P subshell 4p.
Okay.
L is equals to 2, D subshell 4d.
Okay, fine.
L is equals to 3, F subshell 4f.
Okay, good. So I think everyone understood this one. So this you have to write if n is equal to 4. Now I will explain with one example. Just they may ask the question. Find the principal quantum number L and angular momentum or azimuthal quantum number L values for magnesium ninth electron. Amma, we have to calculate this magnesium ninth electron principal quantum number and angular momentum quantum number. To find out this, we have to write the electronic configuration of magnesium. Its atomic number 12. Its electronic configuration 1s2, 2s2, and here 2p, 6, 3s2. This is magnesium electronic configuration, right? Now, it's having 1, 2, and this is 1 and 2. And here it's a p orbital having 6 electrons, 1, 2, 3, and 4, and 5, and 6. And here 2. And now count the electrons, which is ninth one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yo, this is Amma. This is ninth electron. For this electron, principal quantum number value n, and for this electron, angular momentum quantum number value L. So What is its principal quantum number value? Simple. Because of these electron present on which shell, principal quantum number value ante shell amma. A shell lo undi electron, second shell. That's why here it is n is equal to 2. And L value. ఇప్పుడు L value అంటే n is equal to 2 అయితే పాసిబుల్ L values are 0 and 1. కానీ రెండు రాయలేము ఇక్కడ. L values ఒకటే రాయాలా. అది ఎట్లా రాస్తాం? These L value, these electron present on which subshell? P subshell. So this electron present on P subshell. That's why here L value. If it is for P subshell L value, what is that? 1. So here 1. Okay. For S subshell L value 0. For P subshell L value 1. For D subshell L value 2. For F subshell L value 3. Okay. For example, same question they may ask like find the principal quantum number and angular momentum quantum number for last electron. This magnesium last electron. Either adugutunnadu. So this last electron present on third shell. So the principal quantum number value 3. Okay. The principal quantum number value 3. And this last electron present on S subshell. If it is F subshell, what is its angular momentum azimuthal quantum number value? 0. Till any doubts, identify the principal quantum number value and azimuthal quantum number value for in electronic configuration. They may ask any particular example. ఏదైనా అడగొచ్చు. ఎవరైనా డౌట్ ఉంటే అడగండి తల్లి. You can unmute yourself. I am going to lock the meeting. Okay. Any doubts? Is it clear, everyone? No one are responding. Wise? Are you understand? Okay. The next, write down continuous points. I am removing this one. Shall I? Okay, write down. If the value of n in same if the value of n, that means principal quantum number value same, value of n is same, then the order of energy, then the order of energy, then the order of energy of various subshells, energy of various subshells will be that is S is less than P subshell, less than D subshell, and less than this is F subshell. Example we can take here 4S and 4P and 4D and 4F are 3S, 3P, 3D, 3F. Then next, if the value of L is same, if the value of L is same, but value of n is different. But value of n is different. Then the order of energy will be అమ్మా ఇక్కడ మనకి ఏమడుగుతున్నారంటే in the first condition n value same, s value different, l value different. This case here l value same, s value different. In that case 1s is greater than 2s is greater than 3s is greater than 4s, like this. Or 3d is greater than 3p. Sorry, less than 4d, not greater than, less than. And this is less than 5d and this is less than 6d. And here it's depends on if l value is same there, which is more highest quantum number, principal quantum number, that is more energy. ఇక్కడ principal quantum number value increase అవుతుంది. Here angular momentum quantum number value increase అవుతుంది. Okay, and one more, this was explained by the angular momentum also. Angular momentum. The orbital angular momentum equal to the orbital angular momentum equal to root of L into L plus 1 h by 2 pi, or this is the formula to calculate the orbital angular momentum, or square root of L into L plus 1 h. Okay, L into L plus 1 h. Example, for this example, these two are formulas. రెండిట్లో ఏదైనా తీసుకోవచ్చు. These two are formulas for orbital angular momentum. For example, orbital angular momentum of s sub shell and p sub shell. Orbital angular momentum. Orbital angular momentum of s sub shell. For s sub shell, what is that? S sub shell is nothing but that L value. For f sub shell, s is equal to 0, L value 0, and instead of L we can substitute this one 0. So what we will get here for s sub shell? For s sub shell 0 will get here, and p sub shell, for p sub shell p అంటే 1. For p sub shell L value is equal to 0. 1. For p sub shell L value 1. So 1 into 1 plus 1 h by 2 pi. How much there? 1 into 1 under 2. Root 2 h by 2 pi. Or if you substitute this formula, root 2h. Okay. This is the formula for to calculate the angular momentum of orbital subshell. This and this both. Anyone we can take it. I am removing this one. And the next point, the number of electrons. Not completed this one. The number of electrons. The number of electrons in a particular subshell. In a particular subshell. In a particular subshell. The number of electrons in a particular subshell is equal to 2 into 2L plus 1. This is the formula, the maximum number of electrons in particular subshell. But maximum number of electrons in a shell and the principal quantum number we discussed already. The maximum number of in a shell, the particular shell, what is the formula? 2n square. Here 2 into 2l plus 1 square. Example, if you take example here, for S subshell, L is equal to 0. For P subshell, L is equal to 1. For D subshell, L is equal to 2. For F subshell, L is equal to 3. If you substitute these all in this formula, we'll get maximum number of electrons in S subshell. 2 into 0 plus 1. So here total 2 only, 2 electrons. Here after substituting, we'll get here 6 electrons. You can do this one. And here it will get 10 electrons. Here it will get 14 electrons. Okay. And do you know the shape of the subshells? The shape of the orbitals. Shape of orbitals. S orbital shape. The shape of S orbital is a spherical shape. Spherical. And shape of P orbital is dumbbell shape. Dumbbell. And shape of D orbital, double dumbbell shape. Double dumbbell shape. And shape of F orbital, complex shape. We can't draw this one. Complex shape. Later we'll discuss about the shape of these all orbitals. In this one only. S orbital, P orbital, D orbital shapes. Any discuss this. Okay. Shall I remove this? Now this one completed. Angular momentum quantum number. Okay, I am going to remove this page. And next one, keep the heading magnetic quantum number. Magnetic quantum number. Magnetic quantum number or orientation quantum number also. Or we can call this one orientation quantum number. Orientation quantum number. magnetic quantum number or orientation quantum number. So this was given by Lande. Given by Lande scientist. It represents the orientation of electron cloud. Orientation of electron cloud. That is nothing but orbital. Represents the orientation of electron cloud. That is nothing but orbital. Under the influence of magnetic field. Under the influence of magnetic field, each subcell is further subdivided into orbitals. Divided into orbitals. So orbitals is nothing but the electron cloud. The electron cloud is known as orbital. The electron cloud is known as orbital. Magnetic quantum number. The value of all magnetic quantum number depends on angular momentum. So here value of magnetic quantum number. This was represented by m, small m. Magnetic quantum number. The value of magnetic quantum number that is m. Describe these different distribution. These different distribution of electron cloud. That means here the value of m that equal to all integral values from all integral values from minus L to plus L, minus L to plus L, including 0, minus L to plus L, including 0. That means here the value of m equal to minus L to plus L. I will give examples here. We'll get the clarity. Okay, I will give examples. I am going to remove this one. For example, from starting onwards, I am giving this is n value, that is nothing but principal quantum number value. This is n. And here I am writing L values, and here I am writing M values, magnetic quantum number values. These are n. Okay. If it is n is equal to 1, n is equal to 1 is nothing but that is the first shell. If it is n is equal to 1, what is the L value? The possible L value only 1. And that is 0. And this is S subshell. And that to 1s subshell. Is it clear? మరి ఇక్కడ m values ఏంది? These m values are depends on L only. It have been minus L2 plus L, including 0 అమ్మ. ఇక్కడ L వాల్యూ అంటే మైనస్ L వాల్యూ ఎంత ఉంటుందో అది మైనస్ L2 ప్లస్ L, మైనస్ 0 ప్లస్ 0 ప్లస్ 0 అని తీసుకోవాలా. సో దట్ మీన్స్ హియర్ m value, it is not possible to take minus 0 plus 0, 0. That's why m value also 0. 0 అంటే దాని మీనింగ్ ఏంటంటే, ఇక్కడ నేను చెప్పాను ఆల్రెడీ, 0 అంటే దాని మీనింగ్ అక్కడ ఏం లేదని కాదు, దాని వాల్యూ 0. అంటే ఒక వాల్యూ ఉంది, దాన్ని 0తో రిప్రజెంట్ చేస్తున్నాం అంతే. ఇట్స్ హ్యావింగ్ వన్ వాల్యూ, ఓన్లీ వన్ వాల్యూ. ఓకే. And here L is equal to 0, always M value also 0. So this is S orbital. S orbital. And that too that we can call as 1s orbital also. ఎందుకు ఇది ఫస్ట్ షెల్ లో ఉంది కాబట్టి. Now if n is equal to 2, the principal quantum number value 2, the possible angular momentum quantum number values are L is equal to 0 and L is equal to 1. If it is L is equal to 0, we know already that is S subshell. And that too this belongs to second shell, that's why 2s. And L is equal to 1, that is P subshell. And that too this is 2p. When comes to this one, M value 0. Why? Because minus 0 plus 0, 0 ante 0 ne vastadi. Adi kuda S orbital. S orbital. And that too 2s orbital. ఇప్పుడు m వాల్యూ ఇక్కడ ఏమొస్తుంది? ద L is equal to 1. That means minus 1, 0, plus 1. అంటే మనం ఏం తీసుకోవాలా? మైనస్ 1, మైనస్ L2 ప్లస్ L, ఇంక్లూడింగ్ 0. అంటే మైనస్ L తర్వాత మైనస్ 1 తర్వాత వచ్చేది నెక్స్ట్ 0ని, 0 ఆఫ్టర్ ప్లస్ 1. సో టోటల్ 3 వాల్యూస్. హౌ మెనీ ఆర్ దేర్ హియర్? 3 వాల్యూస్ అమ్మ. అంటే మనకు p ఆర్బిటల్స్ ఎన్ని ఉంటాయి? వి హ్యావ్ p ఆర్బిటల్స్ 3. సో this is px orbital, py orbital, pz orbital. దీంట్లో ఉండేది -1, దీంట్లో ఉండేది 0 అండ్ దీంట్లో ఉండేది +1. టోటల్ 3 ఉంటాయి. కాబట్టి ఇదేంది? p orbital. Did you understand? One more. If you take n is equal to 3, n is equal to 3, the possible L values are 0 and 1 and 2. If it is 0, S subshell. If it is 1, P subshell. If it is 2, D subshell. Okay. If L is equal to 0, if L is equal to 0, the M value also 0. Obviously that is S orbital. If L is equal to 1, L is equal to 1, M value also -1, 0, +1. Total 3 orbitals ఉన్నాయి కాబట్టి p orbital. If L is equal to 2, D subshell. అప్పుడు M values ఏమొస్తాయి? -2, -1, 0, +1, +2. టోటల్ ఎన్ని ఆర్బిటల్స్ ఉన్నాయి? 1, 2, 3, 4, 5. 5 ఆర్బిటల్స్ దేంట్లో ఉంటాయి? D ఆర్బిటల్స్. This is D orbital. And one more. If L is equal to Here n is equal to 4. n is equal to 4 అంటే l is equal to 0 and l is equal to 1, l is equal to 2, l is equal to 3. l is equal to 0 means that is m value also 0 only. And if it is l is equal to 1, m value -1, 0, +1. If it is l is equal to 2, the m value -2, -1, 0, +1, +2. Total 5 వచ్చినాయి ఇక్కడ. Here this is s orbital and this is p orbital and here it is d orbital. And if it is l is equal to 3, nana, l is equal to 3 అంటే ఏమొస్తుంది m -3, -2, -1, 0, +1, +2, +3. Total how many orbitals came? Total 7. So that way this is f orbital. అంటే సింపుల్ గా మనం ఏం ఐడెంటిఫై చేయొచ్చు అంటే, ఫర్ ఎగ్జాంపుల్ ఇప్పుడు 3D తీసుకుందాం. 3D లో దిస్ థర్డ్ షెల్ టెల్స్ అబౌట్ ద ప్రిన్సిపల్ క్వాంటమ్ నంబర్ వాల్యూ, దిస్ సబ్ షెల్ టెల్స్ అబౌట్ ద యాంగులర్ మూమెంటం క్వాంటమ్ నంబర్ వాల్యూ. దీంట్లో మ్యాగ్నెటిక్ ఫీల్డ్ తోటి ఆర్బిటాల్స్ గా డివైడ్ అవుతాయి. That's why this orbitals tells about the magnetic quantum number value. I think everyone understood. Is it clear or are you getting any doubts? Okay, is it clear? If you get any doubt, you can ask in chat box, no problem. This finding of quantum numbers are important. Okay, I'm going to remove this page. Is it clear, everyone? Are you understanding? Uh, 20th electron of vanadium you are asking, right? Okay, Vaibhav Surya, 20th electron of vanadium, right? Now vanadium electronic configuration. So this is 22. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. సో 20 అడుగుతున్నాం అంతే కదా. ఓకే, ఓకే. 20 electron magnetic quantum number value. The 20 electron will be here only. ఎందుకంటే 2, 2, 4, 10, 12, 18, 20. ఇక్కడ ఉంది 20 electron. So we have to find the quantum numbers for this లాస్ట్ వన్. దీన్ని ఫైండ్ అవుట్ చేయాలి అంతే కదా. ఓకే, ఫైన్. ఇప్పుడు దీన్ని అన్ని ఫైండ్ అవుట్ చేద్దాం. ప్రిన్సిపల్ క్వాంటమ్ నంబర్ వాల్యూ n అండ్ యాంగులర్ మూమెంటం క్వాంటమ్ నంబర్ వాల్యూ l అండ్ మ్యాగ్నెటిక్ క్వాంటమ్ నంబర్ వాల్యూ m. ఓకే, ప్రిన్సిపల్ క్వాంటమ్ నంబర్ వాల్యూ మీన్స్ హియర్ these n value, these electron present on which shell? Fourth shell. So that's why its principal quantum number value 4. Okay, and this electron present on which subshell? S subshell. We know already for S subshell L value, L is equal to 0. ఈ electron S subshell లో ఉంది కాబట్టి L value 0. Okay, if it is L is equal to 0, the M value -0 + 0, 0 + 0. ఇది పాసిబుల్ అవుతుందా? కాదు. కాబట్టి L is equal to 0, Always m value also 0. Did you understand? అలా కాకుండా దీన్ని తీసుకుందాం, నీకు ఇప్పుడు క్లారిటీ వస్తుంది. 1 2 3 4 3d 5, ఆ 3d 2లో 1 2 లాస్ట్ ఎలక్ట్రాన్ తీసుకుందాం. ఫర్ దిస్ ఎలక్ట్రాన్ దిస్ ఇస్ dxy dyz ఇట్లా తీసుకుందాం. ఇది నేను తర్వాత చెప్తా. ఇది తీసుకుంటే ఇప్పుడు